put this one about peer versus centralized communications, taking out middlemen. And there's some examples of decentralized versus centralized networks. I put that slide in, which is similar to what we drew on the board. All of you should get used to just making that little drawing. And that bottom line is just the hash. I just wrote the word hash. SHA-266 is a specific form of hashing. And actually, we can do a little exercise on hashing here. Oh, like hashing security, sorry, hashing. This one. Hashing was developed by the NSA. And that SHA-256 is the hash, like the hash function. It's a function. There's this little one. Hashing a process. You make apple juice out of apples. You can't then make an apple back out of the apple juice. But you know that the apple juice came from an apple, but you can't make an apple again. You could use some other example of that, like chicken McNuggets has been used. You can't, make the chicken back out of. People can try this. So if I put in John Dennis, that's the hash of John Dennis. So that's a nice little thing, a little exercise you can do in class. If you use SHA-256, every time you write John Dennis, it produces that.
Okay.
So if I wanted to prove that I would only have to have the hash as my name, and then if I wanted to check was my name used somewhere else, I would see does the hash match? Is there a matching hash? But it would never be my name. I would just know that I did it because my hash is there, right? And if I put John D. Dennis, it gives a completely different hash. Right, so you can use these little things in your class.
Okay, so what do I do with that hash? Can I use it for some identity or?
Yes, absolutely. So it's used as a digital signature of the thing that you hashed.
Okay.
So whatever data you hashed is the simple digital signature, and I think this is called hexadecimal. It's not binary. It's hexadecimal, and I think it's 42 characters long. If I'm not, just quickly, let's just do a little thing. Just type in what is the length of a SHA-256 hash? I think it's 42.
What's the length of the hash?
Yeah. Oh, yeah. Can I right click and it'll tell me? No. How many characters?
32, 40, 64. So this is SHA-256. That is 64.
64?
Yes.
Okay. All right. Doesn't look like 64, but it could be, yeah. Yeah. All right. And I might be wrong. This says actually it could be base 64. We have to look up, is base 64 the same as hexadecimal? Because these are the sorts of things that make you a lot smarter in the class, right?
Yeah. And what is that SHA-256 supposed to be? All this SHA-1?
Yeah. So that is just the name of the function that you apply. So it's a mathematical function, a very complicated mathematical function.
Okay.
That
you say it's SHA, or is that SHA?
You say SHA-256. SHA-256. Yeah. This is what I was saying. So whenever you create a hash, you get the unique hash. Why are we confident it's unique? It's because it says that the chances of producing two hashes the same is bigger than the number of atoms in the perceivable universe. So it's like these sorts of weird things that right? This is a game I played in class. This is something else I have to show you as a way to, it's like a classroom game where you have these, but you have to, I've got the kit here. All right. So something to look forward to. I have all the pieces to make with digital ID cards. This would be like a game you could play on day 2 or day 3. In fact, that's how I first got into training. I went to a class in Amsterdam of the people that made this game, and then I thought, oh, this is a great game. I'll be able to sell this. Here it is, TradeLens. I'll be able to sell this game, and like nobody wanted it.
Every day around the world, millions of shipping containers are in motion. An incredible achievement of logistics, coordination, and communication. But legacy data systems and manual document handling cause friction that costs both time and money for businesses and people throughout the supply chain. TradeLens is a digital shipping platform powered by blockchain that enables unprecedented.
Sorry, I've just realized on this slide, I know what happened. I need to delete the image on top of the slide.
But for example, John, if another person with exactly the same name as you creates a hash on the SHA-256, it will be the same one, no?
It would be the same, yeah. So producing so you would want to have enough different things, like my address, you would hash together my whole ID, more or less. It would be John Dennis, date of birth, where you live, so you know it would have to be a unique combination.
Yeah.
Right, sorry. So you can, I'm going to do this again because you can see it, all right? And then we'll call it a day because I think this is a nice.
Every day around the world, millions of shipping containers are in motion. An incredible achievement of logistics, coordination, and communication. But legacy data systems and manual document handling cause friction that costs both time and money for businesses and people throughout the supply chain. TradeLens is a digital shipping platform powered by blockchain that enables unprecedented transparency, collaboration, and efficiency in global supply chains. TradeLens provides control and management of shipping data and supplies innovative apps to every stakeholder in the supply chain: shippers, freight forwarders, intermodal operators, ocean carriers, ports, terminals, authorities, financial service providers, and more. To illustrate some of the ways TradeLens enables collaboration and reduces friction, let's follow a shipment of laptop computers from inland China to their final destination along the west coast of the United States. Using the document sharing capabilities of TradeLens, the shipper can submit shipping instructions to the carrier, who accesses the information to draft a bill of lading for the shipper's review. Once a final bill of lading is verified by the shipper and carrier, TradeLens makes it accessible to the customs broker, the authorities in the port of entry,
so everybody can see it
at the destination. All along the supply chain, access to shipping data and information is managed by TradeLens's sophisticated permissioning model. It controls who can add, view, and update information at each stage of a shipment, and provides a blockchain encrypted audit trail of all critical actions. The benefits of TradeLens really deliver when the planned turns into the unplanned. Due to a sudden shift in inventory demand, the shipper requests the cargo be diverted to its distribution center in eastern US near Savannah, Georgia. Following the request, the shipment is rebooked on another vessel, requiring a change to the manifest and a reissued bill of lading. Using TradeLens, the carrier can create and publish the amended bill of lading to the platform for all permission parties to see. At the customs broker, the new information is updated into the shipment's import declaration for timely submission to US Customs. With TradeLens, any permission party can find the shipment through a range of search parameters, such as equipment number, bill of lading number, booking number, and more. Viewing the transport plan, they can see the key milestones on the shipment's timeline. TradeLens supports more than 120 planned, estimated, and actual events, all tracked instantaneously, giving detailed insights up and down the supply chain. In the case of this shipment, supply chain partners downstream are notified of the vessel change and are able to coordinate and manage the impact of the destination and timeline changes. Global trade is an incredibly complex system, but with TradeLens, and blockchain technology, we now have a trusted solution to support industry-wide innovation. TradeLens, trade made easy.
It's a shame that the real world collaboration didn't work as well as the blockchain collaboration, but that was similar to the beer game in that in the beer game we only had 4 people that all wanted insight and transparency into what's happening. In these very complicated, that was a powerful, the matrix. It said we've got all these people doing things and everybody needs to know what else everybody else is going on. How do you build a system of trust? You report things, people trust that data is correct and can use the data.